of the coast course. We're getting through inquiry question 3 now, so we're not far from the end of this unit of work. Today we'll be looking at long-term sea level change, because another thing that affects the coastline of the UK and whether the erosion and weathering processes are very impactful or not is what the actual sea is doing itself. And you have to realise that the sea level can change, and it's changed historically. We've already looked at Dalmation Coasts, and we've mentioned rias and fjords, but we're going to look at those in a little bit more detail. But secondly, also, what about future sea level rise, where we're thinking about how climate change will lead to higher sea levels and therefore will increase the power of the sea. So this is kind of a summary slide of what you should be aware of by the end of the lesson. You should be aware that sea level change can be short-term or long-term. So by short-term, we mean things like storm surges or increased wave activity due to tropical cyclones. Remember also that one sort of more minor angle is thinking about tectonic activity. Which had major impact, however, was the Boxing Day tsunami of 2004, where a submarine earthquake triggered an enormous tsunami which killed many thousands of people. Also remember that if sea level change occurs more slowly in the past, it has occurred more slowly in the past, we can get submergent features. And if it falls slowly, we can get emergent features. So the features we'll be looking at today will be rias, fjords, Dalmation coasts and raised beaches. And we'll also be focusing on future sea level rise in terms of what the impacts of climate change might be. So this lesson is about the long-term sea level changes, and lesson 17 will be about storm surges and tropical cyclones, i.e. the short-term sea level changes. So a word the examiner loves is the word temporal, and temporal just means time. So if you see the word temporal in an exam question, it just means temporal sea level change, just means sea level change over time. So remember there are a number of scales on which this can happen. So you can have day-to-day changes in sea level, so high and low tides, and remember that high tide, for example, destructive waves have far more power because they are closer to the base of the cliff or further up the beach. Atmospheric pressure can also vary the sea level. So when pressure is low, sea level is lower because it's not being sucked up as much. When the other way around, it's being sucked up, by low pressure. And when there's high pressure, the sea is not as impactful. Low pressure, the sort of atmospheric pressure it's talking about really is if you had a tropical cyclone, which is an area of intense low pressure, or a storm in the UK, then low pressure would lead to higher sea levels because literally the sea is sucked up slightly, it bulges slightly and becomes a bit higher. Winds also vary the sea level. If it's very windy, the sea is whipped up, so you can think of it as being higher to some extent. And wave height, of course, wave height varies according to wind speed on that day, whether it's stormy at sea. Remember those swell tides that surfers wait for, where there's been a storm out in the ocean the day before, and the surfers wait for the waves to arrive on the coast. Also, sea level change, if it's not just short term, can be longer term, over several thousands of years. And these are the factors we'll sort of be looking at more today. So if we're looking at sea level change, remember that sea level change can occur because the land falls or rises, or because the sea falls or rises. So it's both of those aspects, but relatively they're going to increase sea level rise. So if the land falls but the sea stays the same, it's as though sea level has risen. And you'll be saying to yourselves, well, how can the land fall? That doesn't make sense, but we'll talk about that in a moment. And equally, how can the land rise? Well, again, we'll talk about that in a moment. But overall, these changes are either eustatic, which means they occur everywhere on the globe, they're everywhere, or they're local, and they're known as isostatic. So that's the thing to remember. Global changes in sea level are eustatic, and local changes in land level are called isostatic. So make sure you pause the video and note those key terms down, which are very important. So during the last ice age, 10,000 years ago in the UK and Europe, as you can see on the right here, this is where the ice extended across Europe. Obviously it was further north than this, but we've got it covering the whole of northern Russia, the whole of Scandinavia, parts of the Netherlands, parts of northern Germany, and across the north part of the North Sea, and all the way across Scotland, most of Ireland, and only a small proportion of southern England and southern Ireland were unaffected. So people normally think of the extent of the last ice age in England as on a line from the M4, along a line of the M4 motorway. So that's from London to South Wales. But as you can see here, it didn't quite extend out into the fens around the Norfolk coast on the east there. But basically, this is the extent of the ice age. So if the temperature remained below 0 degrees, the ice was all over the land during this time. And when it disappeared at the end of the ice age, what might have happened to the sea level? Well, that ice had to go somewhere. Remember that the water cycle is a closed system, so the ice doesn't just disappear. If it melts, it goes into the sea. So that caused a eustatic sea level rise. So you can see here on this map, which is of the world 120 million, 10,000 years ago during the last ice age, the sea level was a lot lower because the water had been taken into the ice. And then it's at least 120 metres higher today than it used to be. And you can see here, that the ocean extended basically a lot less far, and that once it melted, sea levels rose everywhere. So this is showing the sea melting, so 27,000 years before present. Underneath here is the UK, obviously, and the extent of that ice sheet. You can see the direction that the ice is travelling, so it's expanding northwards, westwards, eastwards and southwards here at this point. And this 19,000 years ago, or before present rather, the ice has already retreated slightly from the North Sea there. And then 15,000 years before present, it's only present in northern Scotland, the mountains of Northern Ireland, and some of the islands between Scotland and Norway. So you can see equally along with that, the sea level change here. And these are known as eustatic changes. So the actual sea has risen or fallen. So when the ice was on the land, the sea level was lower. And when the ice had melted, the sea level was higher. And these are eustatic changes that affect all the oceans on the globe. However, in addition to that, there were isostatic changes. So when the land is covered in ice, like it is here 27,000 years before present, ice weighs a lot. And that actually pressed the land down that was covered in ice, causing it to further sort of dip towards the sea. And as the ice melted, we had the thing called isostatic recovery or isostatic readjustment, where you can imagine the UK a little bit like a seesaw with the pivot of the seesaw around the middle here. And once the ice disappeared and the weight disappeared off it, this end of the seesaw started to rise. So in other words, it looked like sea levels were falling. And isostatically, the southern parts of the UK tipped towards the sea as though that was now the heavier end of the seesaw. So it's kind of adjusting itself back to a balance point, I suppose. But that has meant that sea levels around the southern parts of the UK and the southern parts of Ireland have actually isostatically risen. Remember, the sea has not, the sea did change after the end of the Ice Age, but in addition to that, the land in the south has also been submerged slightly by this release of ice from the northern parts of the UK. So remember, isostatic change is a localised change in land height, which sort of results in a change in sea level. So plate movements can cause isostatic change, so you can have tectonic upthrust. So when you've got isostatic recovery, this would be a good definition for the examiner. Isostatic recovery or readjustment is the upward movement of a continental mass when released from the pressure of an ice sheet. So that's the kind of definition that you want in your notes. But if you understand the concept, it's the land readjusting after the weight of ice has been removed. And remember that eustatic change is a global change in the volume of the oceans. So that causes change in sea level. Eustatically speaking, we've looked at the past. Ice ages cause eustatic changes in terms of sea level rise. And remember that global warming currently is also a eustatic change because it is causing expansion of the oceans. There isn't more water. Well, there is more water in that there's the melting of the ice sheets. But remember that warm liquids take up more space. So if the oceans are warmer, they will expand and therefore relative to the land will rise. So this is the kind of process of coming out of an ice age. As the temperatures fall in stage 1, glaciers and ice sheets advance and the sea levels eustatically fall because the water has gone into the ice. Stage 2, the ice thickness increases and the land is lowered because it's squashed by that weight of ice. In stage 3, the temperatures increase as we're coming towards the end of the ice age in the last 10,000 years ago. The ice melts, sea levels rise eustatically, and we're going to talk about some submergent features, i.e. they are submerged by the rising sea levels, and we'll talk about those in a moment. This is also known as marine transgression because the sea is transgressing, i.e. trespassing to some extent on the land. And stage 4, as the ice sheets continue to melt, the pressure on the land decreases isostatically and we get some emergent features. So remember that we'll get emergent features in the UK, in Scotland and Northern England, and we'll get submergent features in the UK in East and Southern England, basically. Nowhere else really, apart from maybe just the south coast of Ireland. In the background here, you can actually see a fjord, which is not something we have in the UK. This is in Norway, and a fjord is a drowned glacial valley, and we'll talk about that in a moment. So some more key terms to get your head around here. Accretion. If you accrete something, you add to something. So this occurs when sediment is added to a landform, such as a river delta. So if you say that rivers accrete at the delta, it means that they drop their sediment by deposition. And you can obviously form new landforms by doing this. You build up a material, a delta grows out into the sea. However, it's normally balanced out by subsidence, depression of the land caused by the newly weighted material. So you normally have kind of a balance really at river deltas, for example. And remember that post-glacial isostatic readjustment is the uplift of land. So when we have all these sea level changes going on, we have submergent features, and the ones you have to know about, the ones basically submergent, remember these are the ones that are made by rising eustatic sea levels, so rias, fjords and Dalmation coasts. And then emergent features are features where, relatively speaking, it could be isostatically, the land is rising, so you end up with raised beaches, for example, with fossil cliffs. So we'll have a look at a couple of those. So here on the left we have the UK's most famous ria, the Kingsbridge Estuary in Devon, and this was a river valley. So the river flowed from the coast, from the land out into the sea in Devon. However, at the end of the last ice age, when the sea levels melted and there was eustatic readjustment or eustatic global change, the sea flooded back up the river valley and it has basically made a much larger estuary than would have been there before. So if you dive to the bottom of this Kingsbridge Estuary, you would see basically a river valley with and it's been submerged basically by this rising sea level. So the sea has infiltrated back up the estuary. This is Sognefjord Fjord in Norway on the right here. Fjords are common in New Zealand. They are common in Norway. These are areas that formerly had glaciers which extended to the sea. So this would have been a glacial valley, quite a different shape to this Ria Valley here. So glacial valleys, you're not studying glaciation, but they have these steep, as you can see, truncated sides. So the glacier literally bulldozes its way down the valley from inland towards the sea. So we're coming down the valley towards the sea here. And these truncated spurs, they're known as, have been chopped off by the glacier advancing down the valley. When the ice age is over and the eustatic change occurs with sea level, the sea floods back up the glacial valley. So the way to remember the difference between these two things is ria sounds like river, so that's a submerged river, and fjord is the other one, which is a submerged glacial valley by the sea. So fjords are by the sea. So here's a little comparison of the two. I suppose the examiner could be super mean and give you a comparison or maybe a photographic evidence of both. Rias are generally V-shaped because rivers make V-shaped valleys. Fjords are generally U-shaped because they are made by glaciers truncating the spurs on either side of the valley. Wider and flatter normally. So because the rias, remember, have to be by the sea again, so they're at the estuary or delta part of the river, so they're not like the river further inland, so they are wider and flatter. If you imagine what an estuary would be like if it hadn't been flooded. Fjords remain steep-sided and narrow all the way to the ocean because the glacier doesn't expand as it reaches the ocean, it just calves, which is spelled C-A-L-V-E. They carve into the ocean. Rias are deep at the mouth because the basically the river scours out the kind of base there of as it comes, the river has more volume and the river gets deeper towards the mouth of the river, as you know if you think about your water cycle geography. However, fjords are shallower at the mouth because generally speaking the glacier approaches the ocean and then curls over the lip at the edge and doesn't over deepen the end of the valley. The reason for this is because the gradient changes, so the glacier is moving more slowly because it's steeper at one end of the valley, so the glacier moves more quickly. By the time it gets to the sea, it's generally speaking warmer, and the gradient is flatter and the glacier moves more slowly, so it doesn't scour the edge of the fjord as much, so you get a bit more shallow. Shallow is a relative term, you still be able to jump in, but anyway. Rias have lots of branches, dendritic drainage like a tree. Dendritic means like a tree. So you can think of the picture of a catchment area with the main river valley with all the little branches coming off. That's what it would look like on an aerial map. And fjords have a rectangular drainage pattern. So rectangular means that you would see a straight-ish glacial valley with right-angled hanging valleys and little glacial valleys hanging off the side. It wouldn't be tree-shaped pointing upwards like this, it would be at right angles to the main valley. So Ria is a flooded river valley and a fjord is a flooded glacial valley. If you want to see a little bit more on that or understand a little bit more, there's some good guidance in the textbooks, but also you could just have a little YouTube Google and have a look at some typical, you could look at the Kingsbridge estuary so you can see what it looks like, and also look at Sognefjord, which is spelled S-O-G-N-E in Norway, or the Nordfjord in Norway, which is another big fjord. Another feature of submergent coastlines is of course Dalmatian coastlines, and you'll hopefully remember that this was a feature of concordant coastlines too. So we've seen some synopticity here. We're looking at inquiry question 1 here, features of the coast, and we're combining it here with inquiry question 3, where we're looking at post-glacial features, I suppose. It's a relic feature from the glacial age, and you can see quite clearly here these long bands of rock that run parallel to the coast of Croatia, and they look like islands, but they're basically, what's happened is the sea level has risen post the last ice age, flooded lower lying areas of the land on these concordant bands of rock, and caused these sort of long lagoon shaped pieces of water in between these long island like structures of land. Now, the opposite of these submerged features are emergent features. So remember that in the UK, if you were looking for these, you would be looking for these in Scotland or Northern Ireland. You would not be looking for emergent features on the south coast or in southern England in any way. So raised beaches and fossil cliffs, and they're called fossil cliffs because they're full of fossils, because they are old, generally speaking, because they predate 10,000 years ago. Are the feature that you need to know about. So when the sea level falls, wave-cut platforms and beaches get raised up, so they become above the level of the wave activity. So no more action takes place because the sea can't reach them anymore. So we get a line of degraded cliffs which front what was once a wave-cut platform, and we have beach deposits behind it. It's usually due to post-glacial isostacy, which basically means where the land has rebounded after the weight of the ice has been removed, or in the past former higher global sea levels. So we do see these features in other parts of the world due to different sea levels in the past, but they would be even older because this will be to do with, for example, in the Cretaceous period when the Earth was a lot warmer, they would have had higher sea levels in the past, and as the Earth cooled down over time, you might see some of these more relic features, but they would be even older than the ones you would be expected to know about, which are post-glacial. So here is a picture of, or a diagram of, a raised beach, an emergent landform. So you can see here there's the present day beach, so the ocean is acting upon this beach and these cliffs here, and here you can see a raised beach where the sea once was acting upon with the former cliff line. So it looks like sort of terraces coming down to the sea, and you can see a lot of these on the Isle of Arran in West Scotland. So they can be a result of eustatic or isostatic changes. So Scotland is rebounding upwards, so the ice sheet has that caused it to sink is recovering, and this is sort of in the case of Arran, it's to do with isostatic readjustment, but remember they can occur for other reasons. So we had so this is Isle of Arran here. We can see a picture of raised beaches on the Isle of Arran. So these caves are not on the coast. So this sea here does not reach these caves. It isn't entirely clear because they're not as high as they are on the diagram here. But here you can see these caves have been formed by seas 10,000 years ago. Think of it at the end of the Ice Age, before the ice melted, and these caves were formed then. And this, you can see the vegetation here, which indicates that it's not currently being inundated by the sea, because this grass wouldn't grow if the sea was constantly covering it. Remember that the sea is very salty and very few plants are salt tolerant. So here we have some more raised beaches. So here on the Isle of Arran, so you can see raised beach here, which is because it's not got any marine processes occurring on it, it is now vegetated. So you can see it here, raised beach. Here you can see these pebbles up here are from a former raised beach and cliff. These are marine pebbles, and this is the land that has basically been exposed when it isostatically readjusted. So this is a former beach. The sea would have come up to here previously, and is now, this is the level of the current beach now. Oh, this is in Devon. So I think these are in Arran, but this is in Devon, and yes, I'd say that never happened. This one in Devon is not a result of the last ice age. It is far before that. It's to do with a previous geological period that is not to do with the last ice age. So if we're thinking about we've thought about long-term sea level change in the past, which is historic, but what about the present and the future? So if we think about the fact that more than 60% of the world lives on or within 60 kilometres of the coast, it matters what the sea is doing, because there's 60% of the world population will be impacted by present and future sea level rise. So the Intergovernmental Panel on Climate Change gives a best case scenario, or a business as usual scenario, of 1 metre rise in sea level by 2100. Now, you may think that this doesn't sound very much, but it does. It matters a lot if you're at sea level. So 1 metre, it covers the land basically. So if we have rising sea level around the world, we get increased cliff and beach erosion. So we have, Hapesbury, Holderness. The reason for the accelerated erosion of those areas has been due to sea level rise, because the sea is more effective in its erosional strength if it's coming from a higher base. More coastal flooding occurs through inundation and storm surges, because remember that another impact of global warming is an increase in storm surges. Salinisation of farmland. This means that salt incursion from the sea can occur onto farmland. Remember that this marginal land in some places around the coast is used for grazing. So you could have salinisation of farmland, which impacts dairy cattle, sheep, etc. The grass dies, they can't eat it. Our water supplies could get salt incursion, because it could seep into aquifers and other sources of water that we use. So we tap aquifers in the southeast of the UK due to inadequate supply. we might get destruction of coastal ecosystem habitat. So you need to think about the social, environmental and economic impacts of sea level rise. Here's some actual facts and figures that you might want to use. So Bangladesh and the Nile Delta. Bangladesh is a very low-lying country in Asia, and if there is a 1 metre rise in sea level, 9% of Bangladesh and 15% of the Nile Delta in Egypt could be inundated. Remember that Bangladesh is one of the most populated countries in the world, and it certainly cannot afford to lose 9% of its land when there are some food shortages already in this country. The Maldives in the Indian Ocean is already an island state that is suffering from sea level rise. Some of these places in the Indian Ocean have already become uninhabitable, and people have had to move to New Zealand and Australia to escape sea level rise because the lands are maybe coral atolls that are very flat, and 1 metre rise covers the whole island. So Los Angeles, Miami and London are all at sea level. New York to some extent as well is at sea level. So these cities would be under serious threat of inundation by a 1 metre rise. And I suppose you could think about on the east coast of Britain in particular, where land is generally speaking lower, road and rail links and power stations and farmland could become inundated. So these are kind of a combination, a bit of an overview of some of the impacts of those changes. In the next couple of lessons, you will be looking at more specific examples of coastal flooding and inundation in high income countries and low income countries, and doing a comparison. So having a look here at this is the UK after a rise of 84 metres. So 84 metres, if all the world's ice melted, so there's no going back from that, you can't refreeze the ice, this is what the UK would look like. So you can see that the whole of the east coast right to the Midlands has gone, London's gone, we're stuffed down in Esher. So the south coast has gone, we've got inundation here in Devon, we've eroded most of the coastline towards Birmingham. Scotland would be okay, as you can see, because remember this is also isostatically readjusting upwards still after the last ice age, although Edinburgh would become flooded. But you can see it becomes a bit more fragmented, like there are islands rather than one landmass. So you can see also the northern coast of France here also affected. So that's what would happen. So we have some facts here that is probably useful to pause and have a look at, but it's showing you nations on the left here classified by population in low-lying coastal regions, and on the right here nations classified by proportion of population in low-lying coastal areas. So 100% of people in the Maldives live in a low-lying area, and you see the Bahamas, Bahrain, Suriname, the Netherlands, Macau, Guyana, Vietnam, Djibouti and Bangladesh. Now with it, the Maldives is I suppose a low-income country, but it's not poor in the sense that it has good development because of tourism. But as soon as you get to Suriname, Macau, Guyana, Vietnam, Djibouti and Bangladesh, you're into countries that are low-income countries really. And these countries, you see here that 50% of Vietnam lives in coastal regions, so this will be devastating. Bangladesh, 40% of people live at the coast or in low-lying areas. See here, low-lying coastal regions. China has 10% of its population living in low-lying coastal regions. So we have another chart here. So you can just compare the two and have a think about how in the main, with a couple of exceptions, Japan, Egypt, the USA, and Bahrain here and the Netherlands, most of these countries are LICs. So we have to be considerate of the fact that these countries will be affected to a far greater extent by rising sea levels than countries that can afford to do something about it. So we've talked about the Maldives disappearing. We're going to talk about the Sundarbans in Bangladesh, which is a coastal area of Bangladesh characterised by mangrove swamps. Other impacts of climate change and coastal flooding is that we would get increased wave erosion on the Arctic coast. Remember that the Arctic is at the North Pole. We'd have more destructive waves due to a greater number of storms and depressions and cyclones. So not just will we have coastal flooding, but also we will have greater rates of coastal erosion and coastal change. And also, in addition to that, we've got a greater magnitude of storms, but we don't know what the actual is. There is business as usual scenarios predicted by the IPCC, and then there are worst case scenarios and scenarios that governments are currently working on to mitigate climate change as we speak. So that's it for the features of sea level change. You need to be aware of historic sea level change, submergent and emergent coastlines, and why those features occurred. And then also be thinking about the future of sea level change. And the next two lessons will be focusing on what happens. No, so the next lesson will focus on short-term change like storm surges, but after that we'll go into more detail on high-income and low-income countries and the impacts of sea level rise on them.